Hi, my name is Virpat Pimanakam. This video presentation is for 305242 computer networks. Today we're going to talk about transport layer. So we have introduction, transport layer protocols, and user datagram protocol, and transmission control protocol. So the transport layers provide a process-to-process communication by using a logical connection. The transport layer service is providing services to the application layer. So in the transport layer, it is process-to-process communication. Addressing of it is port numbers, and it have ICNN ranges. So it has well-known ports, register ports, and dynamic ports, and encapsulation and decapsulation, multiplexing and demultiplexing, flow control, pushing or pulling, flow control at transport layer and buffers, alert control, sequence numbers, and acknowledgement, combination of flow and error control, sliding window, congestion control, connectionless and connection-oriented, connectionless services, connection-oriented service, and finite state machine. So network layer versus transport layer. In network layer, so it is host to host, but transport layer is its process to process. So we can create a transport layer protocol by combining a set of services. Simple protocol. Our first protocol is a simple connectionless protocol with neither flow nor error control. We assume that the receiver can immediately handle any packet it receives. FSM, simple protocol. It is unidirectional protocols. So this is for picture. FSM for the simple protocol. Flow diagram. Flow from client, request to server. Stop and wait protocol is a connection-oriented protocol called a stop and wait protocol, which uses both flow and error control. Both sender and the receiver use a sliding window of size 1. The sender sends one packet at a time and waits for an acknowledgement before sending the next one. To detect corrupted packets, we need to add a checksum to each data packet when the packet arrives at the receiver site. So in stop and wait protocol, it has sequence numbers, acknowledgement numbers, FSM, sender and receiver, efficiency, pipelining. So in stop and wait protocol, if its checksum is incorrect, the packet is corrupted and silently discarded. Every time the sender sends a packet, it starts a timer. If the timer expires, the sender resends the previous packet or keep a copy. Only one packet and one acknowledgement can be in the channels at any time. So this is a picture of stop and wait protocol. So this is FSM for the stop and wait protocol. Flow diagram for stop and wait protocol. The third is go back N protocol. To improve the efficiency of transmission, multiple packets must be in transition while the sender is waiting for acknowledgement. In this section, we discuss one protocol that can achieve this goal. In the next section, we discuss a second. The first is called go back N. So it has sequence number, acknowledgement numbers, send window, receive window, timers, and resending packets, and FSM, sender receiver, send window size, go back N versus stop and wait, go back N protocol. Send several packets before receiving acknowledgements. The receiver can only buffer one packet. Sequence number is modulo to exponent square m, 2 square m, where m is the size of the sequence number field in bits. Acknowledgement numbers simulative the sequence number of the next packets expected. Send window for go back N. Send window is the sequence of numbers of the data packets that can be in transit or can be sent. An abstract concept defining an imaginary box of minimum size equal 2 square m minus 1. The send window can slide one or more slots when an error-free ACK with ACK no greater than or equal as f and less than n. A modular arithmetic arrives. Receive window, an abstract concept defining an imaginary box of minimum size 1 with one single variable, Rn. The window slide when the correct packet has arrived, sliding occurs one slot at a time. This is FSM for go back N protocol. This is for sender, and this is for receiver. In the go back N protocol, the size of the send window must be less than 2 square m. The size of the receive window is always 1. Flow diagram. Although Act 2 is lost, Act 3 is simulated and served at both Act 2 and Act 3. Efficient. Each time a single packet is lost or corrupted, the sender resends all outstanding packets. This has an avalanche effect that may result in the total collapse of the network. Selective repeat protocol. The go back N protocol simplifies the process at the receiver. The receiver keeps track of only one variable, and there is no need to buffer out of all the packets. They are simply discarded. Another protocol called the selective repeat protocol has been devised, which, as the name implies, resends only selected packets. Windows, timer, acknowledgement, FSM, sender receiver. Unlike of selective repeat, timer. When the timer expires, only the corresponding packet is resent. Acknowledgement: the sequence number of the error-free packet received. FSM4SR protocol: sender and receiver. Flow diagram. The size of the sender and receiver window can be at most one-half of 2 square m. Example: if m equals to 2 square m divided by 2, or 2 square m minus 1 equals 2. Bidirectional protocols: the four protocols we discussed earlier in this section are all unidirectional. Data packets flow in only one direction and acknowledgements travel in the other direction. In real life, data packets are normally flowing in both directions, from client to server, and from server to client. This means that acknowledgements also need to flow in both directions. A technique called piggybacking is used to improve the efficiency of the bidirectional protocols. It, it is a design of piggybacking in Go backend. Internet Transport Layer protocols. A network is the interconnection of a set of devices capable of communication. In this definition, a device can be a host, such as a large computer, desktop, laptop, workstation, cellular phone, or security system. A device in this definition can also be a connecting device such as a router, a switch, a modem that changes the form of data, and so on. Position of transport layer protocols in the TCP/IP protocol suite. UDP is unreliable, connectionless, simplicity and efficiency for earlier protocol. TCP is reliable, connection-oriented, and reliability. HTTP is Stream Control Transmission Protocol, is reliable transmission of user messages. So all of these is in transport layer. Thank you for watching.